Hello and welcome back to Statistics1. We are going to organize qualitative data. That's the one without numbers. So what are the ways in which we can... So we collected data, surveyed population through census or observed, right? Or a sample, and we have a bunch of values for a given variable. And we said that the non-numeric variables from last time, non-numeric data, would be called qualitative. And this lecture is all about organizing that data so we can draw some conclusions, look at the trends, and maybe even infer from it. So we start with one of the first methods, which is called frequency distribution. Now, frequency, hopefully you understand that word. How frequently do you go to the store? Like how often something appears. So, frequency distribution definition. A frequency distribution, that's the shorthand for it, of qualitative data is listing of the distinct values and their frequencies. Very simple to do this. We look through the window at a parking lot, see what are the colors of the cars parked in one of the rows, and then say something like this. We create a chart, car color, and then we can have, to easily follow, we can have tally, and then we can have frequency. Usually we just put lowercase f for frequency, just lowercase f, but okay, it's frequency. So now you look through the window at the car lot. We see gray, see white, we see black, we see red, we see green. Do you see anything else? Sorry? Blue? Okay. Great. And then you look at the first car parked. The first car parked was black. The second one parked was green. And you keep putting these tallies through the whole thing. Most of the cars are either black or white. Whole bunch of gray cars as well. Red cars are easily spotted by police, so not too many people are driving red, right? And the green car, just don't have a green car. Just one, that's it. And then blue, right? We should have blue represented as well. There we go. So now you say, all right, I went through the parking lot. I just put a tick mark for every car I saw, every color. And now I just write these frequencies. 4, 6, 8, 3, 1, and 2. the amount over here should total the amount of cars surveyed that you looked at for the color. So in this case, 24. So we looked at 24 cars. So this chart, the entire chart, everything in it, it's called frequency distribution. So I'll just do like this. This entire chart is called a frequency distribution. So when the question, not if, but when the question on your exam and homework and final says create the frequency distribution or show frequency distribution, you are supposed to create a chart of values. You will be also making this chart of values on your project for the data you pick. So frequency distribution is just simply the table with values. The next part is the relative frequency distribution. Relative frequency distribution. So we'll have to write the formula for relative frequency, but let's first get the definition for this. So a relative frequency distribution of qualitative data is a listing. This is pretty much telling you over here, it's a chart, right, of values. Is a listing of the distinct values and their relative frequencies. So frequency is just a number, how many times certain value comes up. How many cars are red? 3. How many cars are green? 1. So that would be frequency. For relative frequency, you have to divide frequency by the total number of cars. That will also give you the probability eventually, or how likely you are to pick at random that car. So relative frequency is equal to frequency divided by number of observations. In our case was 24. Remember I found that number because I need it. No coffee. Number of observations. So in our previous example, we had for red cars, let's say, so red cars, it was like this. Tally, frequency, and now we're going to have relative frequency. So tally, it had 3 lines. Frequency was 3, and relative frequency will be 3 over 24, which is it's exactly 1 over 8, which is 0.125. So relative frequency would be a number. And we can write that as a percent at is.
Is it safe to say that relative frequency is relative to the entire data?
That's exactly what it is. Perfect. Yes. So now, when we have a relative frequency listed, you compute all of them, you would say that there is 12.5%, 12.5% of cars are red. So that's what we have. It's a descriptive measure, right? So we are adding additional column, and you have to compute each one separately. So for black cars, you would say 8 divided by 24. That would be 1 over 3. So you would say approximately 33.33% of all cars on this particular parking lot are black. Now, if you took a sample, let's say the parking lot has 100, 120, 150 spots, and you surveyed 24 cars picked at random. Oh, that reminds me to talk about random table one more time. I will. So you picked a sample of 24. You collected the colors. Now you can use this small sample to make a prediction about all cars on that parking lot, all 150 cars that are parked there, or whatever number in population. And you can claim that about 12.5% of those cars should be red. And about a third of all cars should be black. And I think white cars were right there. There were 6. All right, whatever. So relative frequency will be obtained through the formula, frequency divided by number of observations. You do that division for every single line, and you obtain the percent at which they happen. Then you display this in pie charts, histograms, and all of these other things that we can use Excel for to find and draw. So now, when you are in a software, there is OpenOffice, and even Macs have something like this. So you can come up with your variable car, our chart. So now I'm in Excel doing all of this. We have gray car, we have white car, we have black car, we have red car, we have green car, and the blue car. I'm going to skip tally here. I'm just going to do the frequency and relative frequency. This was 4, and then 6, 8, 3, 1, and 2. And you can quickly select all of the numbers and one extra empty field, and click on auto sum to give you the total, 24 cars. And now for RF, we put mathematical equation. You start with equal. You pick this cell, and you say divided by 24. There's also a way to do that. And now you can, let's say, cut this to 3 decimals. And then you pick this little square in the corner and just drag it down, including 24, because you want to see 100 or 1 on that, right? And there's your relative frequency. So it's very quick to display this data. Now, you will choose data without the names, variable names. You'll click on Insert. And over here, as I said, you have your pie chart. Now, obviously, you're going to make something that looks nice. And they give you, now you go obviously with some kind of style. right? So blue is gray and white is orange and then black is gray and red is yellow and green is blue. I mean, that's obvious from the picture. You can actually go and change the color of each one of these individually to match the color of the car. And then you can just play with different styles that will display different information. All of the styles are all the way on the top, right? So you can pick something nice. So we'll talk more about these things. We still have, 4 minutes? So we'll talk more about graphical representation. We just did the pie chart. We'll talk about others because I need to talk about that random number chart, some issues on homework. So we'll continue this next class.